Now we're going to take a look at problems 8 and 9 on your review sheets. Number 8 is something that's called an Atwood's machine. Basically, it's just two masses, a 2 kilogram on the right and a 5 kilogram on the left, both attached via a string that goes over a large pulley. And our job is A, what is the acceleration of the system if we just let these two things go? And B, assuming the system starts from rest, how long will it take for block A, this one here on the left, to fall 2 meters? And this one's 5 kilograms, this one's 2 kilograms, so you should be able to figure out the 5 is heavier, it's going to be the one that falls, the 2 kilograms is going to go up. Now, we can't say that up is positive and down is negative because up for this block, if the 5 kilogram goes up, that's because the 2 kilogram is going downward. And if the 2 kilogram one rises up, that's because the 5 kilogram is going downward. So up for the 5 kilogram is down for the 2 kilogram and vice versa, which might seem a little complicated, but it's not that bad. Basically, what we're going to take a look at is any force that's going to make this system go clockwise is positive. And any force that's going to make the system go counterclockwise, we're going to say is negative. Now, and every time we have more than one block, we have to set up equations for each object. So for part A, we're trying to find the acceleration. For block A, which is the one on the left, what are my forces? Tension is trying to make this system go clockwise, so it's going to be positive. The force of gravity is trying to make this whole thing go counterclockwise, trying to spin the pulley in the other direction, so it's going to be negative. That's why it's tension minus force of gravity for block A. That's going to equal the mass of block A times acceleration. For block B, force of gravity is the force that's going to try and make this pulley go clockwise. So it's positive, whereas tension, going in the other direction, trying to make the system go counterclockwise, is negative. Put the two together, force of gravity of B minus tension, amount of forces, so that's going to equal the mass of block B times acceleration. We're going to add these up, simultaneous equations, just like we did for number 6 and number 7, if you saw that video. And what do we get? We get tension in the top and negative tension in the bottom. So when we add them up, they cancel. So on the left side of the equation, the forces that stay are force of gravity B, and that's going to be a positive force, minus force of gravity A, that's a negative force, so it stays negative, is going to equal the mass times the acceleration of both objects added together. Solving for acceleration, we factor A out, leaving us the masses in parentheses, divide by the masses into the denominator on the left side, and then we just have to plug in our numbers. Force of gravity for block B is the mass, 2 kilograms times 9.8 meters per second squared. For force of gravity for A, 5 kilograms times 9.8 meters per second squared, all divided by their masses put together, and I get negative 4.2 meters per second squared. And remember, negative means counterclockwise, which means the 5 kilograms is going to be the one that falls. And that makes sense. So a negative does make sense. We should get a negative answer. And now let's move on to B. B says, if it starts from rest, how long is it going to take block A to fall 2 meters? Well, it's going to fall 2 meters, negative 2. And remember, that's because it's going to be going in the counterclockwise. For 5 to fall, it's going in the direction of my mouse, which is in the negative direction. That's why it's a negative 2. V naught is 0 meters per second. Acceleration is negative 4.2 meters per second. We just solved for that. And time is what we're trying to find. We're going to use the equation D equals V naught T plus 1/2 AT squared, because that's the equation without VF in it. V naught is 0, so that term cancels, leaving us with D equals 1/2 AT squared. Doing a little bit of algebra, we move the 1/2 over, we move the A over. 1/2 becomes a 2 in the numerator, the A gets moved to the denominator, and we do a square root to get rid of the squared. Plugging in my numbers, which I did right here, negative 2 for D, negative 4.2 meters per second squared for A, and I get a time of 0.98 seconds for the 5 kilogram block to fall 2 meters. Now let's take a look at number 9. In this one, we have an amusement park ride known as Magic Mountain Superman. Powerful magnets accelerate the car and its riders from rest, so V naught is 0 meters per second, to 45 meters per second, which is about 100 miles an hour, which is really fast, in a time of 7 seconds. We know that the mass of the cars and the riders is 5,500 kilograms. And the question says, hey, what force has to be exerted on this stuff in order to make this happen? Well, if you try to solve for force right away, our equation would be F equals ma. because the total force acting on this thing equals mass times acceleration. And I know that the mass is 5,500 kilograms, but at the start of this problem, I have no idea what the acceleration is. We don't know it, so we can't use it. We have to find it. So anytime you get a problem where you're given some kinematic stuff, initial speeds, final speeds, distances, and times, and you're being asked to find something in the forces, what is the force acting on this thing? Typically what we have to do is find acceleration using kinematic stuff so that we can use it to find the force, which is what we're really looking for. So we know V0 is 0, Vf is 45, and time is 7. The thing that we don't have and do not care about is d. We don't care about distance. We don't have it. What we really want is acceleration. So I picked the equation without the d in it, which is Vf equals V0 plus at. Doing some algebra to solve for acceleration, I subtract V0 to the other side. That's why we have Vf minus V0, and divide by time, which is why it's in the denominator. I get 45 meters per second minus nothing divided by 7 gives me an acceleration of 6.43 meters per second squared. Once I have that acceleration, I can very easily plug into F equals ma. Mass is given at 5,500 kilograms. We just solved for the acceleration, telling me that the net force acting on these cars and the riders is 35,365 newtons to accelerate them up to 100 miles an hour in 7 seconds.